triangle midsegment theorem. So let's talk about what a triangle midsegment is. It's kind of in the name, okay? So if you have a triangle, the midsegment is just some segment that connects the midpoints of two sides. And you know what a midpoint does to a segment, right? It splits it into two congruent segments, right? So here is an example of a midsegment of a triangle. These are the midpoints of those two sides. Everybody agree?
Yeah.
And so that means that these segments are what? And these segments are congruent, okay? Well, you can connect the midsegments of any two pairs of sides, right? You do it like that, or like that. So how many midsegments could you draw in a triangle? Or 3. As long as it's no more than 3, right? Okay? So they connect the midpoints of any two sides of a triangle. So there are 2 things to know when you have a triangle midsegment. 2 things, right? Everybody hear me? 2 things?
Yeah.
All right. So the first thing is, thing number 1, and it's in red here. The midsegment, the segment that joins the midpoints of two sides, right, is first, 1, parallel to the third side. Okay? That's the first thing. So you see in the diagram here, you see this midsegment, and you see the third side that's not connected by it. Those 2 segments are parallel. Okay? So that's the first thing. You got to know 2 things. And the second thing is that the midsegment is half the length of the third side. Okay? So what are the 2 things you know if you have a triangle midsegment?
Parallel to the third side.
And half its length. Now, instead of saying the midsegment's half the length of the third side, how else could you state that, like from the other point of view? The third side is twice the length of the midsegment, right? That's equivalent, right? Depending on what you're doing, you could describe it either way, right? It's both valid and true, okay? So 2 things, parallel to the third side and half its length, all right? So let's quick look at this here. Again, they're doing this paper folding. Let's say you have a paper triangle and you got a midsegment and a triangle, right? Yeah, so I'm not like Archie Craftsy handing out. Some teachers like, that's fine. I mean, that's their thing. They like to cut out, spend like their entire day cutting out 26 paper triangles and handing them out. No, thank you. I got see my desk. Anyway, so,
We just wanted to add to the pile, that's all.
yeah, doing a fine job adding to that pile. So, if we take this, where the midsegment is this top part of the triangle and fold it down, right? Change the shape, doesn't it? Okay? And so what do we have there?
Trapezoid.
It looks like a trapezoid, doesn't it?
Yep.
Okay.
Under my shapes.
So, where were they getting at here? They're going to put
Under like a square.
right. So we could show that it's twice the size, right? By folding up the other parts onto it, couldn't we?
Yeah.
Right? You guys just take a look at that. You know, I think you get the idea, right? They're just kind of demonstrating how it's twice or half the size of the third side.
Yeah.
That's fine. Let's go over to the next page here. Now here's an important way to look at it. Again, we're always trying to connect things we learned before, a way we learned something before, to a new thing. Okay? So we learn this new thing, and you got a couple properties, right? The midsegment is parallel to the third side and half its length. So let's think about a transformation that will describe that. Okay? So remember, translations. Right? When you get done with them, the corresponding sides are what?
Here,
Congruent and also
I always say supplementary parallel.
parallel, right? And the angles are what? Corresponding angles congruent, okay? So keep that in mind. So let's take this triangle here, okay? And over here, what they're going to do is they're going to take this triangle and translate it, slide it over. It's isometric, right? Okay? So then we have this thing here. So now this guy is obviously congruent to that, and what? That segment is congruent and also what to? Parallel, okay? Got it? And these guys are also parallel. Good, right? Now, let's take this triangle again, right here. We've already slid it over to get this one. let's do this. Let's translate it up here. Everybody with me? Okay? So, this segment right here, let me do a different color maybe. Okay, so this segment here ends up right here, and it's the same length, is it not? This segment is also over here, isn't it?
Yeah.
So here we have this segment by 2, don't we? Because they're congruent after the translation. And here is this segment by 1. So does that show you then that now when we go back and think of this as a mid-segment, as a translation, there's one of these segments, and down here from this translation is 2 of them. So do you see now why? Another way to explain we learned before, that the mid-segment is half the length of the third side. Does that make sense? Okay. So always be thinking of stuff. So this is so let's say if this is length AB, right? Because this is AB, then what's this length?
Twice.
2AB. Right?
I mapped.
And over on the previous page, instead of AB, because we approach it differently, they just had X and 2X, okay? But now you kind of see why, because you're connecting it back to stuff you mastered with, okay? All right, so now that we've sort of informally proved it, we can use it, right? So use the theorem to solve for different values in the triangle. Okay, so here's a triangle. How do I know that's a mid-segment? It didn't tell us.
The line through the middle, the midpoint thing.
It clearly connects the midpoint. How do you know it connects? How do you know that and that are midpoint? Because definition midpoint, right? You got congruent on both sides, right? With me? So even if they don't say it's a mid-segment, it's marked so that you know. All right, so how might we find the measure of y? It's a mid-segment. Here's the third side. What's the measure of y?
I'd say about 9.
Or exactly 9. Half of 18, right? I guess they did. So y must be 9 because it's half the third side. What about x?
I'd say.
Why is x 8?
It's only one part of it.
If that's 8, there's your midpoint. That's congruent, so that's also 8. Okay?
16.
Yeah, but x is 8. The whole side is 16. You're right. Okay? Let's look at the next one. Now we know, here's what will help us here, that the mid-segment is one of the things to the third side? There's 2 things. What's one of them? Half it and what? It wasn't like it was 3 weeks ago. Parallel. Right? Parallel. That's what's going to help us here because I'm looking at angles, right? Okay? So if these 2 are parallel, right, does that make these 2 parallel lines cut by a transversal?
I'd say yeah.
You'd say yes and be correct. What is this angle pair here? Corresponding, and if the lines are parallel, you know they are what? So x is 76, right? Okay? Now what about y? Because, well, the mid-segment's half of this, but also you can say this is twice the mid-segment, right? So y is 14. You get any idea?
Yeah.
Okay? And then get a little more complex than it. I think you're getting a grip of it. So 2 things, right? With me?
Yeah.
Mid-segments are what to the third side? Half and parallel to it, okay? And look, here's one with all 3 mid-segments drawn in. Got that? So how many triangles are in there, by the way?
4. No, 5.
No 6.
What?
He's right both times. There's 4 smaller triangles and 1 big one, right?
I'd
Okay.
say 5.
All right, so x, if this is 18, it's half that, so 9. But what about y? So if this is the mid-segment here with y, here's its third side. What's the measure of y?
16.
I thought y was half the third side.
Oh. I'd say 4. I'd say 3.
What's the length of the third side? This segment's 8. What's this one? What's y equal?
5.
8. 8.
8. Because the third side is 16. What's half of 16?
8.
Oh. So it turns out the mid-segment is equal to just one of these segments here. Because one of these segments is half of the whole thing because it's a midpoint. All right? Just keep circling back around, don't we? Okay? All right, let's go down here. You guys are going to take a look at these, and you're going to solve for any variables that you see in there, x and y. So quietly, take a few minutes, read these, set them up. Because these guys are parallel, and these are corresponding angles, so x equals 86 degrees. How about y? So y equals half of 24, isn't it? Equals 12. Okay? How about,
Mister,
yes,
you have to show me work.
I don't think that's an undue burden, right?
Yeah.
Like, if you just had y equals 12, I'm assuming that's what I have on my answer key. I said, well, I got to assume.
Well, I mean, like, with
Good
X
job.
too.
Well, like, sometimes it
Yeah.
just, right? Okay, how about x here?
16.
So now that's twice, right? Thing
I
on the other
said
side.
16.
2 times 8, 16, I guess they're in centimeters, right? How about y? Let's think about this. What is it? How did you get that? Why? Okay, let me ask you. You're right, but I want you saying these two are congruent. How do you know that? How do you know it's isosceles? Congruent, 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 congruent. The sum of two congruent things equals the sum of two congruent things, and so it's isosceles, right?
Yeah.
Okay?
Great
You
job.
probably had an intuitive sense of that, but I just worked it out, mathematically for you. So this is 70 degrees. So y equals 180 minus 70 minus 70, and we said it was 40 degrees, right? Hmm? We good? Did you get the last one yet? Oh, you have to do something for the last one. Anybody get that yet?
You gotta do. I do. It's a 4.
Well, did anybody get anything for x or y in this one?
I got 18 centimeters for x.
Wait, what'd you get?
18 centimeters for x.
Okay.
And 24 centimeters for y. It's probably wrong.
It is definitely probably wrong. All right, x is fine, right? That's simple. That's a mid-segment, right? So, yeah, okay, x equals twice that, which is 18. We got that, okay? Why? Anybody? Why at all? So, listen, who has some thoughts about how to get after y? Any ideas? I mean, we got a tool bag, right? Stuff we've learned before.
I think it's the midpoint, so you should know.
What? How is y a midpoint? It's a whole segment.
I'd say.
Okay, we need to. That's a midpoint. So yes,
I'd say.
we need to double something. But what? Double. We need a number.
Well, I'd say it's 12. No. 12.
What do you think?
What's 24?
Abby, say it louder. Is
Is
that a right triangle?
Yes.
Is a Pythagorean theorem in our tool belt?
I'd say.
What part of this right triangle is missing? The what? Hypotenuse, which is what in our theorem? Well, it's c, and then it goes into the third as c squared, right? Now you got something else. Go ahead and take it from there.
Wait, so 9. Yeah.
Remember, in that theorem, the hypotenuse is always the thing that goes by itself. Okay?
So 12 plus 9 then, basically?
False.
I don't know what I'm doing then.
144 plus
144
plus 81.
plus 81. I'd say.
225.
Anybody get a value for C?
21.6.
12. I'm gonna go 21.
I don't know how I got 225.
Did anybody get 15?
15.
What? Or not, or for C, for C.
But how do you come up with the other one's
30.
number? Like 12 plus
So it's
3.
12 squared.
Where do you come up with the 3?
3.
12 squared.
So
12
it's
squared plus
15.
9.
Everybody agree with that?
Oh, that's what it is.
Yeah, so it's 1
That's what
4.
that there is.
I agree with that. I do think you're right.
Bit of both. I did not do it all.
I think I wish you put it down.
225.
Is that from a movie?
Well, we don't want C squared. What do we want?
Oh, square root. Square root.
Oh.
It's 15. I knew it.
That's why you should have told us because
I was just making sure
C
you got
is
it.
15.
Now,
The whole thing is just line.
back to somebody said we need something to double. Do we have what we need to double now?
Yeah,
Yes.
good job.
So what does Y equal?
30.
I said that. Yeah.
Who did?
How good of a guess it? See how long it done.
Who said it?
I did.
I didn't hear you. Anybody else hear him?
I did.
Oh, yeah.
Okay. Let's, quiet. We've got, hey, 3 reading questions to look at. Shouldn't take us long. So, to sum up, listen. If you have a mid segment, in what two ways does it relate to its third side? One, it's what? Congruent.
It's a-
Look back and look. It's in bright red. Half the third side and parallel.
But he sent it.
Okay.
Parallel to the third side and it's half it.
I was getting some extraneous information. So these are congruent, right? And we know that these are. So we're dealing with quadrilateral what? A, D, E, F. So, okay? And they want the equivalent of its perimeter. Let's think about this. This is a mid-segment here, right?
Yeah.
So it's equal to half of this whole thing. In other words, it's equal to what? One of those.
It's half of AC and half of AD.
Okay, so what kind of marks could I put on this mid-segment? The double one, right?
Parallel, the double congruent.
Well, right now, just because we're dealing with distance, we're not worried about parallel, okay?
Sure, Bob, let's see.
Hey, let's look at this mid-segment here. It's equal to half of this segment, or just one of them, isn't it? You with me? So this is going to be congruent to that guy, isn't it? Everybody follow me? Okay. So let's look at some choices here. Perimeter. Oh, please, God, tell me you know how to find perimeter.
Add all sides up.
Thank you. Every year. When you multiply things, sounds like perimeter. Oh, add up the sides. So the perimeter of this quadrilateral will be that plus that plus that plus that, right?
Wait, what is base times what times? Like,
Fine.
that's what y'all said.
I like
First,
doing a-
the triangle.
The perimeter of the quadrilateral.
A, B, C, D, E, F, G.
You find it by adding all four sides. I'm just pointing to the ones.
We'll find out.
Listen, hey, can I ask you a question?
Yeah.
So this plus this, do you see other congruencies with a single mark?
No.
Really?
Yes.
Yeah, one.
A.
Okay.
Segment A, B.
So the congruent marks mean that this segment plus this segment could be equivalent to what two segments added together?
A, D, and T, B.
So this and that is equal to this. So this whole side is equal to the sum of those two sides. You with me? Okay. What's this side?
Let me learn.
AB. Now, Let's look at these two on the quadrilateral. Double marks, that plus that. Okay, that could be equivalently what plus what? AF plus what?
That's the
FC, this side, which is side what?
AC.
So if we take side AB and add it to AC, kind of like by substitution, won't these two add up to the perimeter of the whole quadrilateral? So what choice?
Oh, wait, so it's 3. But wait.
It's definitely two. I'm still saying two.
Leave me wrong. Okay,
It's not.
hey,
I'm so.
Hi. Move on to number 2. Oh, let's see. Oh, it's just, I gotta talk about,
We'll find out.
no. Quiet a minute. Let me give you, hang on. Quiet, you're gonna wanna hear this. Because somehow, what's important, I think we talked about a little bit about, right? So we talked about dilations and they had a scale factor, right? Right?
Yeah.
And when we're dilating these two-dimensional figures, right? Either get like twice as big, scale factor would be 2. 5 times as big, scale factor would be 5, right? Area is 3 dimensions, is it not?
Yes.
So, or volume. Okay, length is 1 dimension, right? Right? Area is 2 dimensions, stretch it, right? Length is 1 dimension, area is 2. So, if in 1 dimension we dilate the scale factor of 5,
Yeah.
okay, and then we go to the other dimension, if we dilate it to a linear side of something about 5 times, but it was actually like a square, so we dilated this 5 times 5 and that times 5. What would be the scale factor for the area, the new area? If we dilated each side of the figure by 5,
3.
what would be the scale factor of the area?
10.
15.
Honestly, I don't know.
Okay, how do you find area?
20.
Length times width. And if we're multiplying the length by
25.
5 and the width by 5,
25.
so what do you do to a scale factor then to then get the area scale factor?
Subtract.
How'd you get from 5 to 25?
Multiply.
Multiply by 5.
Divide.
Squared.
You squared it.
Yes.
You follow me? So if you dilate each side, each dimension by a scale factor, it gets bigger, right? 5 times bigger. But its area is actually how many times more?
5.
25. So the scale factor K would be K squared. Does that make sense?
Yeah.
Somewhat, yes.
Look, if it's a 2-dimensional figure,
Uh-huh.
and I say I'm going to dilate this dimension times 5 and that dimension times 5. So each dimension is 5 times larger,
Yes.
but area is length times width. So if the length got multiplied by 5 and the width got multiplied by 5, the area got multiplied by 25. You follow me?
Oh, yes, I
So
follow.
for area, if you dilate something and you want to go find its new area, you got to use K squared, whatever K was. Now think about this one. Silence and let me just walk you through this. These are connected at midpoints, which makes all these other segments mid-segments we just learned about, right? So now that we know they're mid-segments, we know that each one of them is half of their third sides, right? So in other words, if you took the third side and dilated it with a scale factor of 1/2, wouldn't you get that mid-segment length? It's half its length. Are you with me? So we dilate. We good there? We dilate by half, we get from the third side to the mid-segment, okay? So, ratio of the area triangle, CFE. So where is CFE? CFE. So this triangle compared to CAB. the big one. Okay? Would you all agree that, listen, this side is half of the triangle, is half of the big triangle side, right? Okay? And would you also agree that this side is half the other side, right? Half of that?
Yeah.
Okay, what's equal to that, right? Which is half of the whole thing, okay? So all of these sides of the triangle are half as big as the big triangle. Got me?
Yeah.
So that means it was dilated, got smaller, reduction, and the scale factor was what? If all the parts are half the size, and the scale factor of the whole thing was
One size.
1/2.
1/2.
1/2. I said that. Did you hear me?
I did, but then I was stunned by the other answers.
Oh, okay.
Okay,
It's gotta be more.
It's gotta be 4.
so we know that the scale factor going from the bigger one to the smaller one is 1/2. It got half the size. So because in this segment, we just established that triangle is half the size of the big one, right? Okay. But they asked about the ratio of the area, the scale factor for the area. What do they say to do to this scale factor? Square it.
Yes.
What is 1/2 squared?
1/3.
1/4.
Yeah.
So actually, what's
So
right?
for area,
You're right.
shh,
What is it?
right? We have to do k squared,
It's half.
which equals 1/2 squared. What's 1 squared?
1/4.
1. What's 2 squared?
4.
So the area is 1/4 the area of the original. All the sides are half, but remember, for area was squared, so it's 1/4.
So if we just look at how many triangles there were,
1/3.
how did that actually?
But he had 0.
That's one of those cosmic
They
coincidences.
said 4 triangles.
Okay.
And actually, they're
Okay. Hey, notice up here. What's that say?
Equilateral.
What does that mean? All 3 sides are congruent. Okay. Guys, EF since it's connecting midpoints. What's its name? It's a what? Mid-segment.
got that. I had it.
And you know a mid-segment is what to the third side? Parallel won't help us so much here. Did anybody label what they said in here in the diagram? That would be helpful, wouldn't it?
Oh, yeah. I did.
Yeah. EF is, and the other one, AB is 7, X minus 2. They want the perimeter.
So the perimeter of the trapezoid. That's a triangle. Oh, no, it's trapezoid.
By the way, it's also equilateral triangle. That's a mid-segment. Can we do this?
Yeah.
Yeah, but it's also equilateral. Does that help you?
Okay.
Perimeter of the trapezoid, not the triangle.
I don't know, Al.
It's not too on the.
Can I ask you a question? Would it be helpful to find the value of x?
I did that.
How could we, knowing what we know about mid-segments, what equation would we use to find x? This side is what compared to this segment? Twice. I could set the equation up with this being half of that, but I know what happens when you guys see a fraction of equation. You just start urinating yourselves and
Wait, what do we?
sobbing
How do we put
uncontrollably.
it to 180? Find x.
We're not talking about angles here.
That's what I'm saying. How do we find x then?
Well, we're gonna need an equation. We know that this segment, which is 7x minus 2,
It's
is
twice.
twice that one. What's our equation?
2.
Equals twice this.
2.
I knew it was number 2.
So Solve that for X. No, you know how to do that, right? You know how to distribute, yes?
We'll try.
Hey, if I can remember correctly. Oh, yeah, the rainbow.
Oh, wait, no.
Wait, how did you
Right?
Oh, you did two. Oh, I do.
Yeah, because it's twice as long as the mid-segment.
I know.
so sorry.
Ooh, they combined two.
Well, we can't combine any because they're not on the same side.
I got 6.
You do the minus.
You got 6?
I got 3.3 repeat.
6.
I got 6.
So I'm supposed to get 3x, add 2, equals 18.
Oh, okay. I know what I did.
So x is 6, right?
I know my mistake.
So now, could we find, we want the perimeter of the trapezoid, right?
It's literally 60.
No way.
It was an actually 2.
Can we find the length of this side?
Impeccable math.
Can we find the length of this side knowing x?
Yes.
Yeah.
How?
Either 60 or 1.
Plug it in.
No way.
I think
Who
X is
guesses
honest.
that?
Guys, shut it! Shut up! What does EF equal?
20.
20. So this equals 20. What does this one equal?
40.
They can plug it in, but we know it's twice, right? So that's 40. Right? So we know that AB equals 40. Well, to get that perimeter, all we need is the length of those sides.
Oh,
It's an equilateral triangle.
4.
If this side is 40,
That's 4.
what's the measure of this side?
40.
40, it's equilateral. These are equal. What's the length of EA?
It's 100. It's 3.
20. What's the length of this one?
I'm sorry.
So what's the perimeter?
100. 60, 80, 100.
We got all 4 sides.
There's 3 shapes though. Maybe we should have thought.
Yeah, you were there.
Yeah, I really thought I was
100. See, once you know something, right, you really gotta, you're gonna get some questions that make you think deeply about what you just learned, okay, and apply it to other situations. That's what you guys are in this class for, right? It's gonna make you guys some sharp cookies here, okay?
Heck,